Hello everyone, this is Meesha Tandon from Sustainability and Adaptation Planning Foundation, India. I'll be presenting on nature-based solutions for climate adaptation. So let's start and I'll share my screen. Uh, I hope my screen is visible. So essentially, this session is on nature-based solutions for climate adaptation, hosted by Sustainability and Adaptation Planning Foundation and CRESP for International Chamber for Commerce, hosting webinars along the lines of COP28. So this is about our organization. We basically work towards mainstreaming sustainable development for climate preparedness of citizens. And we work towards sensitizing children and youth and professionals. So we do that through interactive workshops, games, cartoons, and other methods. We've also been receiving some recognition for our work. We also do development of school climate resilience plans where the students brainstorm and identify the threats and develop an action plan to combat climate impacts that they're likely to face in the future. We also do some on-ground activities like, cleaning of riverbanks, tree plantation, and recently we've also done a natural farming workshop with farmers in Bundelkhand region of India. These are some of the images from the ground activities we do. Some webinars that we've hosted on integrated water resource management. Uh, we also hosted a webinar on critical urban infrastructure under the Urban Thinkers Campus, supported by UN Habitat. And we've also received certain recognitions. Now, why is climate adaptation needed? Basically, we've been seeing floods and droughts in the same location very frequently now. So we've had South India, Chennai face floods in 2015 and zero day in 2019, where the water reservoirs dried out and there was scarcity of supply for water for supply to the city. These are scenarios which are becoming very, very common now during summers. We've also seen high frequency storms like Fani, like Vayu and Amphan, which rained up to 280 kilometers per hour and caused a lot of devastation. We also see projections for cities like Mumbai, which are likely to inundate by 2050. A lot of areas in Mumbai are likely to inundate under rising sea level by 2050. There have also been floods like the Chamoli flood of 2021, which swept away uh, an under construction power plant with it. And we've been seeing temperatures above normal in Antarctica. So these are increasingly becoming common now. If we look at India in terms of the global climate risk index, India falls under the top 10 countries which are susceptible to the impacts of climate change. What we also see is that India is reporting a high number of casualties, and we are seeing a huge loss in terms of economic values also. So we look at certain examples of case examples of adaptation in this sector. So this is a city called Burhanpur in Madhya Pradesh state of India. This you see is the river Tapi, and along the banks of Tapi here is the city of Burhanpur. This is a underground, this is a tributary to the Tapi, and close to it is an underground tunnel which connects the Satpuras. These are the Satpuras. So the runoff, the subsurface runoff of Satpuras is diverted into this river through a unique method, which we will show you now. So this is an underground tunnel. If you can see, this has been built around a few hundred years ago in the 17th century. This is now, there are depositions of calcium and magnesium here. But this tunnel used to carry water at the foothills of Satpuras and up to the Tapi River. This was developed under the reign of Mughal King Akbar, so that if the river Tapi is poisoned by upstream, enemies, then he'll have an alternate source of water supply for his army. So this is a unique structure called the Kanat structure. If you can see, there are vertical wells which have been made along this tunnel, which carries the flow from the Satpura foothills right up to the river Tapi. The discharge has over time, due to calcium deposition, has reduced from 1 mld to 0.4 mld. Until recently, this underground tunnel was also used for water supply to the city of Burhanpur, but it has now been stopped. Anthropogenic interference and climate change, along with the calcium deposition along the walls of this tunnel, are leading to reduced, water availability in the tunnel. This is another example from Rajasthan, which is a desert state in India. This is a pond named as Gadisar Talab here, and this is another small pond. Now, whenever it rains, even in that time, this is built around 300, 400 years ago, and the makers of these ponds had the wisdom to be able to connect these ponds even in a desert region, so that no overflow gets wasted. So overflow from one pond used to enter the other, and then into a third pond, and so on. So in this way, we have 7 interconnected ponds in this area, which made sure that none of the water that fell in that desert region went to waste. This is an example of how people conserve the water resources in these areas. There are different grades of how water is made available to the communities here. You have the larger ponds, which are available for agricultural uses, for animals, for washing and other. And then within the ponds, there are bawdis, which are sources of drinking water, which provide drinking water to the community, like wells and underground structures. So these structures are made separately, and they usually retain water for much longer, even after the pond has dried out. Now, these are some examples from various states of India, wherein measures towards rooftop rainwater harvesting are being taken to revive dried wells. In Kerala, which is one of the southern states of India, there is a movement called the Maza Polima movement, which has emphasized the need to capture rain and revive the drying wells, which are generally found in each household in the semi rural and rural areas of Kerala. So these are simply connected to the rooftop tin sheds, and then the water is diverted. There is a outflow provided for the first runoff, so that it does not contaminate the water in the ponds. And then after the first runoff, the water can directly be sent into the ponds. They were having problems related to summer water scarcity, and also because of high concentration of iron and other minerals in the groundwater, which was reflecting in the wells. So with this measure, those problems are addressed, because you do get summer water if you harvest, and your mineral concentration is also reduced by recharge. So we also, as I said, help children make school climate resilience action plans. So this is an example of one of the plans that they made like a clean school focusing towards waste management, solar, rainwater harvesting, and water saving plants, and to save electricity. And we've also helped them uh, implement measures towards this, tree plantation activities we did with the students. Now, the last example here is from Bundelkhand region of India, which is one of the dry regions of India. It's a drought-prone region spreading over 2 states of India. This is the Mandakini River basin in the Chitrakoot district of Uttar Pradesh and spreads over Madhya Pradesh also. So this is the Mandakini River. You can see that there is a lot of slope which leads to a flatter terrain as we go down. The river, the Mandakini River, originates around Sati Anusuya and flows through Ramghat, which is an urban area, and then reaches Yamuna in the agricultural belt. So the catchment can broadly be divided into 3 stretches. One is the agricultural stretch that you can see. This is closer to the confluence. Uh, and this is mostly agriculture. This is Yamuna, and this is where Mandakini meets. So I'll probably start from here. So this is the catchment area. You can see there are a lot of hills and greenery here. So from here, the river originates through a lot of springs, and then the river flows through this forested area and reaches the urban area. This is the urban area, and this is Ramghat, which is one of the prominent ghats or stepped entry to the river. So this is in the urban area, and this entire stretch is urban. And then we have the agricultural stretch before the river meets the Yamuna River at confluence in Rajapur. So some key characteristics if we look at, so the catchment stretch has dense afforestation. So what we saw there was that even after even without any rain for 10-15 days, there was a lot of subsurface flow happening. There was a lot of water in the springs, in the waterfalls. So that led to a preliminary conclusion that probably this is a subsurface runoff flow based catchment. So that is why we have proposed a lot of dense afforestation in this stretch of the catchment, so that water is retained more and it's slowly released by the catchment rather than immediate release leading to downstream flooding. Now, what we also suggested here was provision of silt traps in first or second order streams. This is because during monsoons, the entire river, this entire stretch gets heavily silted up. So that indicates that there is a lot of erosion happening which needs to be arrested. Now, when we look at the urban stretch, there is a lot of pollution that is happening in terms of water pollution, because the wastewater untreated, partially untreated wastewater from the cities entering the river. There's waste disposal. There is also a lot of religious uh, tourism happening here, which leads to pilgrims taking a dip in the river, and which further leads to pollution of the river. So because of these parameters, we have suggested that there is a need for pollution abatement measures here, and also provision of blue-green infrastructure in the urban fabric. In the agricultural stretch, we find that the river dries out during summer. So there are almost 6-7 dams, small check dams, which have been built along this length of the river, which is hardly 50 kilometers. So these lead to siltation, and also they trap the flow of the river. So the longitudinal connect of the river is spoiled, and its connectivity with the floodplain is also impacted. So that is why we have proposed that in the agricultural stretch, the ecological flow of the river should be maintained. And because there is a lot of nutrient entering from the agricultural field, there is also a need for nutrient reduction. Now, I'll go on to the next slide. Right. So we proposed an approach which is comprehensive. So we proposed measures towards catchment management, channel management, agriculture, water supply in the city, stormwater management, wastewater management. So the idea is not to look at problems in isolation. We are trying to build a holistic approach to address this catchment management, where we look at measures towards afforestation, early warning system for droughts and floods and other things. Channel management, wherein we look at maintaining longitudinal and horizontal connectivity of the river and the ponds that are in the catchment. Agriculture, wherein we promote more measures towards water efficient farming, climate resilient farming, natural farming, to reduce the pesticide and the fertilizer concentration in water. Water supply management, because Mandakini River is also used as a source of water supply for the city of Chitrakoot, which has a population of more than 50,000 people. So there is a lot of pressure on this river as well. Then stormwater management, wherein we propose measures towards water harvesting at the individual building level as well as the catchment level. And then wastewater management, how wastewater can be treated and reused, and prevention of mixing with of wastewater with the river. So I'll quickly run through some of the solutions that we have come up with. One is that we propose a detailed hydrological study and floodplain and riverside afforestation of Mandakini River. There is also a need to demarcate the floodplain in order to control the encroachment that is happening along both the banks of Mandakini. Because this river is highly fed by springs, there is a need to delineate the springs and their spring sheds and to conserve them. There is also need to restore the ecological flows, as I mentioned earlier. So activities around Mandakini are proposed, like riverside afforestation, and the entire approach that we are using for this is that instead of a concrete based approach, you should have an ecological approach, which is environment sensitive. So try and minimize the impact on environment and develop potential activities which bring together humans and the environment. So river trails for youth along the river through biodiversity park formation have also been proposed. These are images from Yamuna Biodiversity Park in Delhi. So similar biodiversity park can also be developed in along Mandakini, where it can have nature reserve zones, nature trails, nature interpretation center, wetland areas, and habitats for various species can be created through afforestation. And also it will increase the green space available for the public. Now, Chitrakoot literally means beautiful hills. So we need to look at afforestation of these hills again so as to revive them to their original beauty. We also gave a proposal for room for river concept, wherein the river should be allowed to flood. These are some of the images from Room for River, which is a European concept from, I think, Netherlands. These images are from another study which has been undertaken in EU. So here we propose that, similar scope should also be developed for Mandakini River, wherein stretches should be identified where the river can be allowed to flood. We also propose traditional rainwater harvesting systems. Like this is another image for which has been done by somebody else for rainwater harvesting in hillocks. So similar measures can be taken in our area also. Now, we also propose early warning system. Like this is an example from Zaragoza in Europe. Basically, the idea is that Mandakini catchment faces a lot of drought. As I said, the entire Bundelkhand region is prone to droughts. So that is a problem. And along with that, during monsoons, there is sudden flash flooding also happening. So we need similar systems for early warning, wherein they can alert us on trends for drought also and for flooding also. Now, there is a need for developing interconnected ponds in the entire catchment area and contour trenching. These are examples from somebody else's intervention. And we also propose Miyawaki forests to be developed in the area. And as I said, because of erosion, high silt content in the river gets flooded and siltation happens just before the check dams. So there is a need to have openable gates in these check dams so that the water can flow smoothly. There are also three, four water reservoirs that have been developed. A small, there are small dams in the catchment area, and because almost 30% water is lost because of evaporation losses, we can look at options like floating solar panels on these dams so that the evapotranspiration losses can be reduced. These are examples from an EU project for blue and green infrastructure. We can propose measures towards green sponges, blue sponges, slowing down flow in streams, sustainable urban drainage systems, buffer zones, DWATs, water harvesting, and other measures to to develop a chain of green and blue elements. Green elements, we mean parks, swales, and such elements. And blue elements, we mean ponds, rivers, water bodies, water harvesting structures. And an interconnection of these can be developed to help the city, the town, retain as much water as possible and treat as much water as possible before it goes into the river. And this is an example of an interconnected pond sequence along with the cycling corridor that we have proposed along the Mandakini River. So on this side, you have the mountain ranges, the hill ranges, and this is where Mandakini flows. So as I said, Chitrakoot is also a religious town. So Lord Ram spent around 11 and a half years of his 14 years of exile in Chitrakoot. And that is why it has a lot of religious significance. And every year, or rather every month, millions of pilgrims come for a holy dip in the Mandakini River and they walk the entire stretch in the sun. So this development of this stretch will not only act as a corridor, as a shaded corridor for the tourists, but will also be able to divert the traffic from the city. Main roads of the city are along this area, so they can help divert the traffic to the city as well. And these interconnected ponds where the runoff from the mountains will come, can from the hills will come, can also help in recharge. So this is all from my side. Thank you very much. And now we will say goodbye. Thank you so much for listening to our webinar. We might add a second session to it also. So thank you so much.